right, thank you, people. Happy to be here. So I saw a lot of tech people in the audience, and I saw a lot of finance people as well. So I have done both, and I'll talk about that, and we'll talk about how we use machine learning and AI at 2 Sigma, and also how we use Ray. So there are going to be some details about that too. Do I go back here? Oh yeah. So the title is Beyond the Buzz. So I don't see this on this screen. Is that okay? Oh, here we go. Yeah. So Beyond the Buzz, building real-world AI systems for finance. First, a little bit maybe about 2 Sigma. So those of you in the financial space, of course, know 2 Sigma. Those in the tech space often don't know 2 Sigma. 2 Sigma, we call ourselves a financial services company. We were founded in 2001, so almost 25 years ago. Generated positive alpha all these years, every year since inception, which is, I'd say, quite rare for such a large company. Today, we manage over $60 billion, which makes us one of the largest quantitative funds in the world. There's a substantial amount of proprietary capital. We have 9 global offices. Most of the people are in New York, though. We have one big office in New York, another large one in London, and then some other ones around the world. Currently, roughly 1,700 people. And of those people, about 70% of the employees work in research and development. Internally, we call this modeling and engineering. And that is quite high, I'd say, for a financial company. From my point of view, it feels a little bit like a tech company. And that's maybe also the reason why 70% of the employees are in these roles. So a little bit about myself. I'm called what is called head of AI core at 2 Sigma. I came to 2 Sigma in 2018. And before that, I worked in tech. So I just talked to Robert, who didn't know that I worked actually at Google for 12 years before coming to 2 Sigma. And before Google, I was in Japan. I was at another speech recognition company, and I was in Japan again. So, but my whole career, basically, before finance, I was in tech. So, and what did I do in tech? I started really early with neural networks. I remember in the mid-90s actually using neural networks. My whole time, I worked on machine learning models and also infrastructure. And I would, as an umbrella term, I would maybe say complex systems is the best way to describe this. And what kind of applications did I work on? So in the past, speech recognition, I worked on that probably roughly 20 years or so. It was a separate area, right? Today, it's all done by large language models and similar systems. But at the time, it was a really separate area, and a lot of people worked in speech recognition. And I did that. That's how I started out in tech as well. I was also part of the brain team at Google really early on. So we developed things like TensorFlow. I'm sure you're familiar with that, and the version that we had before that. I worked on machine translation, which was really interesting in 2015, 2016, when we, with a larger team, put this, made it really a lot better, such that, let's say Japanese to English or Korean to English was also a possibility. We could translate these languages, which were really hard to do before. I also worked on recommendation systems. Recommendation systems meaning, for example, in YouTube, what are you going to watch next if you watched a whole bunch of videos? Or what are you going to buy next if you are on, let's say, Amazon or something like that? And finally, language models. So a lot of people today only know language models because of ChatGPT, but language models have been out there for at least 50 years. And they were really integral parts to speech recognition and translation systems always, to basically all NLP systems. And so in the old world, the language models were, people did PhDs on language models, and they just dealt with language. So it's a little bit different than what is happening today. So I joined Two Sigma in 2018, and the goal was to build a team around AI. People said to me, well, let's do AI, and because I asked them, what do you want me to do? And because we didn't really know at the time, it was a great chance to build something from scratch. And so first we had to find people, we had to find applications, what to use it for, and problems that we could use our new knowledge and the new tools that some of us brought from tech. Because I've been doing this for a while, I thought, I have 2 slides on hype and history of AI. And I think this is at least a little bit interesting because you wonder where the hype comes from, right? If you open a newspaper or if you open the internet, there's so many claims and people say all kinds of things. And so I made this chart, or we made this chart a while ago, which are just trends of search terms from 2004 to 2024. Unfortunately, it doesn't go back further. This is on Google, by the way. And I just picked 4 different terms, and those are the relative frequencies of how often they're searched on Google. So let's start with the yellow one, that's neural networks. So you see in 2004, it was more searched for than in 2010, and also more searched for than today. And you wonder why, right? Neural networks were definitely used less in 2004 than they are today. So how come, the relative frequency is less? Well, so now we look at the blue curve, deep learning, and you see there's almost nothing until about 2012. And I still remember this, when deep learning, when the first papers came out from, I think from the University of Toronto, somebody created this new term, deep learning. And I go like, what is this? I had worked on this stuff for at least a decade, and I didn't know what it was. And after a while, you figure out, oh, those are just neural networks. They just made up a new name. And this is the blue curve, and that is today a more important word, at least in this world, than neural networks themselves, although it's exactly the same thing. And then 2 more of these, of the terms, machine learning, the red curve, of course, since about 2016, maybe that was, with the machine translation or something like that, when a lot of people got into this more, machine learning has been growing. And the last one, I didn't, on purpose, I didn't use the abbreviation AI, but just artificial intelligence. So artificial intelligence, it used to be a completely different thing than from what people think of it today. Today, people think it's Gen AI. 20 years ago, there was no Gen AI, and people thought it's, or maybe even earlier than that, people thought it's expert systems. So, and you see here in 2022, when ChatGPT came out, this definitely went up. And I have another graph, I didn't bring it today, but if you put in AI, I mean, it dwarfs all these graphs today. So what happened in tech? And this may actually explain, or it does explain, some of the reasons why I thought going to finance is a good idea. So there were all these areas where AI or a certain development really made system quality a lot better. So in around 2010, it was image recognition. You probably remember this, that suddenly people could easily find out what kind of flower you had or what kind of dog it is or things like that. In roughly 2011, one big part of the speech recognition system, the first part was replaced by neural networks, which really brought up the quality of speech recognition a lot, and that helped at Google and at other companies quite a bit. In roughly 2016, it was machine translation. That's also one thing I worked on, and we basically made this end-to-end system, data in English, English in, French out. Let's train the whole system. And this came along with a bunch of other advances in machine learning. This was before transformers, because transformers in the beginning actually didn't work that well, at least when we tried them. So that was roughly 2016, which really helped the world to translate better. Then in 2017, out of DeepMind, we had this games revolution. It started with the Atari games, where a computer could just look at the frames in sequence and learn how to play a game. And eventually, this was extended to many other games, including AlphaGo. Go, you'll remember this, and Go was I don't remember exactly when that was. I think it was in 2017, when there was the World Championship, or the computer against the world champion in Korea, which was a very big deal, and the computer won. So this was quite a feat. And this is also where reinforcement learning really was put on the map, because all the games were trained by reinforcement learning. Then roughly in 2020, we had the protein folding program, AlphaFold, also by DeepMind, part of Google. I believe they even got the Nobel Prize for this recently, or for parts of it. And then in 2022, there were large language models from OpenAI. This was the first one that everybody in the world really knew, but some of these large language models were out there before, right? Companies like Google and Meta and some other companies had put them out and took them back in. ChatGPT was definitely the one that worked the best and is the most famous today. And there are many other examples in ads and search and so on. And one thing that combines all these applications here, there were often very many people who had worked on them for a long time, for decades. And these experts were telling us, your new thing is never going to work. This is too complicated. There's not much improvement possible. And then what in all these cases happened was that a small group of people showed that it's possible to be better than state of the art at the time. And then quickly the whole field would switch to this new way of doing it. I mean, you can see this definitely in speech recognition, in machine translation, and so on. And that's when I thought, that's why I believe in finance there's a similar thing possible. It's taken longer than we think, but we're doing quite well, I think. Anyway, but finance is also a really interesting area to try these things out. So how did these breakthroughs happen? And I have 3 points here. The first one is science. A lot more people really started working on this research, right? Mostly in early times, it was only at universities, but later it was in large tech companies. I mean, when in the early 2000s, there were no really large tech companies other than maybe Yahoo or things like that. But it wasn't the AI research wasn't really done much at that time. And then what also was important is that some people had enough freedom to really question the status quo. They could basically just do what they wanted. So another big piece of this is technology. 20 years ago, cloud compute wasn't really available, and it became, over the last, let's say, 15 years, really easier to access and use. Also, technology scaled and tools advanced rapidly. Today we have things like Ray, which we didn't have 20 years ago. And finally, a thing that really has changed also over the last 20 years is collaboration. People used to work by themselves or in very small groups. And at some point, researchers and engineers started working together more, first within companies, then across companies. This was done by sharing ideas via papers. These are today, freely on the internet. That used to be not the case 20 years ago, or not as much as, at least. And also sharing of code via open source. You would think that has existed forever. In small pockets, yes, but not like it does today. So AI research, what does it really need today? Well, of course, people. You need the experts who can do these things, and these are hard to find and expensive. These need to be people who are not only good, but also can work in a collaborative environment and can communicate with others. And one thing that we find is, and I'm sure that's true for many of you as well, it's often actually pretty hard to have a large group of people work well together in a team, because there are often very opinionated individuals and things like that. And this makes it sometimes tough for them to work together. So the second thing is, of course, technology. We have complex systems and tools, things like TensorFlow, PyTorch, Ray, etc., right? We use compute with multiple GPUs and TPUs and CPUs in the cloud. This is all new in the last, let's say, 10 years. Obviously, a modern development environment with version control, code reviews, unit tests is really a must. This is very typical for tech companies, but not necessarily typical for many companies outside of tech, including finance. So the final part is the research process. Of course, we want to be successful. We want to make companies that make money. We want to grow the companies and so on. But what is exactly research and what do we use here? So it's for us, the vision of the research is key, but finding the meaning and goals of a certain project is really part of this process. And I always tell people, if it's really clear what you need to do, you just need to make a list, then write it down and do it. That's not really what we call research, right? What we call research is you try a thing, you have an idea where you want to go, and you try a thing, and then you go back and try a different thing because it didn't work, and you keep on searching in this space you have some idea of where you want to go, but you don't really know the way how to get there. And what this means is that really patience is necessary and failure is expected. Anybody who has done a PhD knows what this means, right? You're basically, a PhD is often a failure all along, and then in the end you get something together and it's done. So that's exactly the kind of thinking we need here. But that is sometimes hard to explain to other people you work with, that not necessarily every project we do is going to be a huge success. So how do we decide what to work on? There's this great quote by a famous economist, when the facts change, I change my mind. What do you do, sir? And I think that really encapsulates the way you have to think about this. I personally find in tech, in my past, and also today still, many people it's hard to change your mind when you believe something, and it's convenient to not change your mind, but you just need to do this for research. So in our case, what this means is we constantly source new ideas from other people, from papers, we go to conferences, we constantly reevaluate our motivations of why we're doing something. In some cases, you go to the water cooler in the company and people know what to do because they tell you right there, but still it's very hard to do. And this is a very typical problem, and we do allow obviously some failure, as I said also on the previous slide. So some loose rules we go by if the original motivation for the project still applies, number one. Number two is if we're still making progress, and if we have nothing better to work on, no better project to work on, then we'll keep working on this. Because one thing I see is that many people give up too early for not really a good reason, right? And what this means for us is, of course, we are a financial company. Money is important. We strive for maximum practical impact. So some of the things, a certain percentage of the things definitely have to work. So examples of AI at 2 Sigma, we use it in so many different areas, but I just wanted to point out a few areas. So neural networks, I remember when I came in 2018, there was some use of neural networks at 2 Sigma, but not really that much. We have been driving this a lot more, and we're using them basically, in the most cases, for price prediction, and that has been done for a while. I still remember that sometimes I talk to people from other companies, and they tell me neural networks don't work in finance. I mean, that cannot be true, right? What probably is true that maybe in some cases they are hard to make work because they overfit or you don't have the right data or for whatever reason. And this is a typical problem for anybody using neural networks, but I can tell you they definitely work. In our case, sometimes we only use tens of parameters, sometimes we are using millions of parameters. They are trained on GPUs in multiple days on terabytes of data. This is a complex thing. Another large area where we use AI is reinforcement learning. And so Robert said earlier, all these companies that had been using Ray, I think 2 Sigma was probably pretty early too. I mean, I remember that we started this in 2018, and probably we started using Ray in 2020 or 2021, roughly around that time, for reinforcement learning. We went through a couple of iterations here, and we use this for, one of the areas is execution. And execution means, let's say you want to sell 1,000 Google shares in the next hour. You can do this right now, in one batch, or you can wait an hour and do it then, or you can do it one per minute or something like that. And it obviously depends on a lot of factors. It depends on the price. It depends on other things. And doing this right, reinforcement learning is the right tool for this, and that is one of the areas we use it for. So another thing is, just because AI is often equivalent today with Gen AI, so large language models. 2 Sigma has been using large language models definitely since ChatGPT, but also before that, whatever was available before that, in some form. So currently we have a system where we call it the workbench. We use all the normal models by all these vendors, by Google, by Meta, by open source, whatnot. What was difficult in the beginning was that you obviously want IP security, and that's a major factor for usage. You do not want to put your code into these models and that your code goes out to the world. So that took a while to get that right, but now the whole company can use this. And I just listed 2 examples here. So one is feature extraction out of text. This is where we use this a lot. You could, for example, imagine an application where you want to predict the interest rate change after a Fed speech. So you collect all the Fed speeches, and maybe the large language model can help you with this. Please collect me all the transcriptions of the Fed speeches of the last 20 years. And then you look for certain words or things like that, and you can do this all interactive with an LLM. And this is a very typical way of using a large language model. Another important area is, of course, productivity enhancement just for coding and summarization and things like that. I mean, many of you who work in tech probably use it for coding all day long. Same for us. We don't, there are certain rules of what you can use it for, but this is definitely a big help. So what I think what will happen with large language models, at least in our case, more usefulness must be discovered, because the simple applications are definitely useful, but sometimes you see examples in the press that they can do these fantastic things. So we haven't currently not really we have not found that, and LLMs are not cheap to use if you have to run millions of queries through them repeatedly. And finally, it is already for us a standard tool for feature extraction, but it will become more of a tool really for any kind of data we have, right? And this is not just text data, images, possibly also financial data, and so on, anything we can find. So people before, when I was out there, people asked me, so how do you use Ray? You know, yes, we do use Ray, right? As I said, at 2 Sigma. Ray and specifically RLLib, Reinforcement Learning Library, right, is used for many applications at 2 Sigma. So examples are for reinforcement learning research, and for training we use it. We use it for distribution of XGBoost, which is the decision tree model library. We use it for GBMs, generalized boosted models, for distribution. We have a plan for integration with PyTorch for simpler distribution. And we also use it for large language model fine-tuning applications. So a couple of challenges we've had over time. I mean, IP security is in finance, you know, a bigger topic than in some other companies. Very important for us. That took a while to get that right. But the Ray people actually have helped us a lot here. We have integrated this into our main software branch, but Ray is not the only distributed compute framework we have. You know, we use some of the other ones, Spark and Dask and whatever is out there. And you know, just because Robert said at some point, you know, the need for distributed compute has recently so exploded, but I remember, you know, in speech recognition actually, this was in the late 90s, we used a library called P4. I don't know whether any of you remember this, right? This was a C library that ran on all kinds of computers, and that's how we distributed things at the time, which was probably a very, very simple version of what Ray is today. But I just wanted to share that little anecdote that I had remembered. So I have a couple of misconceptions about finance or about investment management, just because so many people ask me about this stuff, right? So I often hear, I want to work in investment management because it's easy to measure results. So from a top level, oh, is the company making money or not? That is of course true, but in the details it's actually really, really challenging. And so one thing is, one big point is data. So large test sets or large data sets are really relatively easy to collect for tech, let's say for speech recognition or translation. You just use a lot of sentences. But in finance, you only have one day at a time. And let's say if you want to build a daily predictor for a company like Apple, there's only one day at a time. And that's not a lot of data to really test anything. So you potentially have to wait for a long time. Also, financial data is scarce and messy. You know, there was, just in the last few years, there was COVID, there was the retail crisis, there was the Ukraine war. You know, sometimes they're corporate actions, you know, dividend payouts and splits and whatnot, right? So this is all very messy with the data that we're using. So the next thing is testing. Many things we test, in some cases we try to use A/B tests, but that's often not possible because there's so much noise in the tests that, you know, they have to run for a very long time to get actually acceptable results, statistically significant results in acceptable times. So often we don't use A/B tests, and then we use simulations. But simulations can be tricky too, because your simulator needs to represent the real world, and that is quite tricky in finance. It's similar to a self-driving car simulator. You know, you can learn your self-driving in a simulator, but you know, you may not see that the sun is shining in your face or the bird is flying against your window or stuff like that, and this is the same in finance. So the next thing is misconceptions is everything is about time series modeling. Again, from a top level, sure, but in reality, really not true most of the time. So we have text data, we have image-like multidimensional data. When people ask me, you know, what helps you to succeed, it's not to focus on time series modeling, it's focusing on the basics. CS engineering skills, general statistics, and what I call, you know, scientific common sense, meaning that you just know what to do to solve, you know, common engineering problems. That actually helps a lot. And finally, and this is interesting, you know, AI will solve all our problems is on the one side, AI will never work. And you can replace AI with neural networks or reinforcement learning. Reinforcement learning will solve all our problems. Reinforcement learning will never work. I hear both opinions from sometimes the same people within 30 minutes. And neither extreme is true. Of course, there's somewhere in the middle is, that's probably right. One thing that I found is learning from data definitely helps in finance. I mean, it seems obvious, but this is not necessarily everywhere accepted. There is, at least currently, no black box that will solve all our problems. And I don't think there ever will be, but so ideal solutions really take a very long time. We also find that humans are clearly needed in this loop. You cannot just let the computer run. Humans need to find what problems to solve, how to solve them, what tools to use, and so on. So we are very, very far away from complete automation here. So finally, research in quantitative investment management is, at least at 2 Sigma, quite similar to tech research. It's a research-driven culture, lots of PhDs, academic collaborations with professors. We actually have one professor who has worked with us for 7 years now, and universities. We go to conferences. We have fewer external publications than many tech companies because it's many of the things we do are too easy to copy, and there's just not a lot of appetite to share this with. I mean, it's a very competitive industry, so we don't really want to share this with others. But what makes it's a really interesting cutting-edge problems. We work a lot on deep learning, reinforcement learning, really any kind of machine learning, and also, we do have a lot of fun, especially in our group, I'd say. So it's not this dystopian, dark world that some people imagine what it is. Well, thank you very much. And I'm going to be here for a few more hours, so if somebody wants to talk to me, please do. I can answer whatever questions you have. Thank you very much.